We're going to compare means from two samples again, except this time they're going to be dependent samples, which means they're going to be matched or paired between the two groups. So again, now we're going to be looking at before and after, or pre-test and post-test on the same person, or some paired, something between groups that's paired, such as twins or couples. It might also be two measurements on the same day, or something like that, where there's some reason that, you know, one value for one sample can be paired with a value from the second sample. So when we can pair data, you're going to use the differences between the pairs. And this is the most important thing about problems like this. We're not going to use the list of data from group 1 and the list of data from group 2. We're going to use the differences and compare the differences to 0. Okay, so if you do get two lists of data, you can use your calculator to calculate the differences for you. You don't have to do them one by one. And I'll just quick show you an example of that. So in your stat menu, you edit and you'll have lists. So whatever your first list is, I'll just put in a few numbers. So you put your first list in, and then you're going to put in your second list. And again, they'd have to be matched in pairs, so whatever you have on the left side needs to be the pair to what you have on the right side. They need to be in the same order. And once you have your two lists in, you want to go over to list 3, arrow up so that you've highlighted the list name, L3, and then down here you can see it says L3 equals. And you can tell your calculator that L3 equals L1 minus L2. So I'm going to put in second 1 for list 1 minus second 2 for list 2 and hit enter. And now all the math is done for us. We have all of our differences in list 3. So now we can use list 3 to do a t-test or a confidence interval, or to do one variable stats and find the mean of the differences and the standard deviation of the differences. So the differences are all calculated automatically if you just tell the calculator that L3 equals L1 minus L2. So again, once you're done with that, then you have to make sure that you're telling the calculator to use list 3, which is the differences, to do anything else you want with a paired test. Okay. The null hypothesis is that the two samples are equal. There is no difference. In independent samples, we used mu1 equals mu2, or there's no difference. If you subtract them, you get 0. When we're doing dependent tests, we're looking at the mean of the differences. The mean of the differences, or mu d, equals 0. Okay. So you're only using one list, and that list is the list of the differences between the two groups. You calculate the mean of that list of differences. The null hypothesis is that the mean of the differences equals 0. Okay. So here's our notation. D is the difference between the values for a matched pair. So that would end up in list 3 when you do list 3 equals list 1 minus list 2. So the list that you end up with in list 3 is a list of the differences, which are D. We have mu D, which is the mean of the differences for the population. We're going to use the notation D bar, which would be the mean of the differences for the sample. So this would be the mean of list 3, if you were to calculate that. The standard deviation, S with its subscript D, is the standard deviation of the differences again. So that would be the sample standard deviation for list 3. And n is the number of pairs of data. So if you have 25 pairs, you'd have, we'll just say A over here from list 1 and A over here from list 2. There's a pair. And there's a pair of data. And there's another pair. So the number of pairs, even though you have 6 data points here, 2 A's, 2 B's, and 2 C's, and it's going to be 3. So we're only looking at how many pairs there are, not how many total numbers there are in your data set. So a little bit different notation for pairs. Again, we're going to use a lot of D's because we want to look at the differences between the two groups, not the individual data for each group. Okay. So requirements, we have to have dependent or paired data, has to be simple random sample, and you're looking for sample size greater than 30. Remember, that's the number of pairs. And if the sample size is not greater than 30, make sure that your distribution is normal. So the equation, okay, looks a lot like the equation we used for sample means, except you're substituting D in for X for the sample mean. We use a subscript D on the mean, and we use a subscript D on this sample standard deviation, just to remind us that we're using differences. Okay. But in your calculator, you'll be using just the regular TTest and TInterval. Which is the same as what we did when we compared one sample mean to a population mean. Because right now, or here, we were comparing one sample mean to a population mean. Over here, we're comparing the mean of the differences of two groups, which gets you down to one mean, to a population mean of the differences, which your hypothesis says should be 0. Okay. So it's in the calculator, we're going to be doing the same tests, same functions as we did for comparing a sample mean to a population mean, simply because we're just using, even though we have two groups, we're just using the list of the differences, which narrows it down to one group, and comparing that to the differences mean, which should be 0. So here's our example. We're going to look at accuracy of weather forecasts from 2 days ahead and 4 days ahead of the same day. So say they're forecasting for Saturday, 2 days ahead would be the forecast for Saturday that was given on Thursday, and the 4 days ahead would be the forecast on Tuesday for Saturday. So again, forecasting for the same day, but 2 days ahead and 4 days ahead. We want to know if one is more accurate than the other. So what we're going to do, remember we have two samples here, but they're going to be paired because they both are the forecast for the same day. So we have pairs of data, and we have to remember to keep them in that order. Okay. And we have to use the differences between the pairs of data. So let's check the requirements first. We need simple random sample. It doesn't say in the problem, but let's just assume it is for the sake of doing an example. We need sample size greater than 30 or normal. Our sample size is not greater than 30, our sample size is 5, so we don't have that. But temperature follows a normal distribution. So we can assume that we're working in a normal distribution. And we need paired data, and we do because we're forecasting for the same day. So each pair of data is a forecast for one particular day. So let's summarize. First thing we maybe want to do is find the differences. Okay, so let's do that in the calculator. So what I'm going to do is clear all the lists from before. So I'm just going to go up to the list name and hit clear, and go back down, and arrow up to the list name and clear. Now that our list is empty, I'm going to put in the 2 days ahead data into list 1. And then go over to list 2 and make sure that I put in the data for 4 days ahead in the same order as I put in the 2 days ahead so that our pairs stay together. And then we can go over to list 3 and say that list 3 equals list 1 minus list 2. And there's our differences. So I have the differences listed down here. We can do one variable stats on the list of differences to calculate the mean of the differences and the standard deviation of the differences. So under your stat menu, if you go to calculate, we're going to use one variable stats. And we need to tell the calculator to use list 3 because that's where the differences are. And there's our information. So we're using the notation D bar to represent the mean of the differences. And it's X bar in your calculator, so that would be 0.6. And SD, the sample standard deviation of the differences, is SX on the calculator, and that's 2.408. So let's write down those numbers. 0.6 and 2.408. Our sample size n, there's 5 pairs. Those are what we use for n, and degrees of freedom is n minus 1 and minus 1. It's 5 minus 1. So we use degrees of freedom of 4. Keep our data here. Writing hypotheses, we're going to say the mean of the differences equals 0 for the null hypothesis. And the alternative hypothesis will be, in this case, not equal to 0. Because it's asking if the predictions are different. Okay. So the p-value method we can calculate a test statistic. We use 0 for the mean of the differences because that's from the null hypothesis. And we get a fairly small value for t, 0.56. If you were to look that up in the t-table with degrees of freedom equals 4, so going across row 4, our t that we calculated is less than the smallest number that's on the table, which is 1.533 in that row, which means our p-value has to be greater than, if you go up to the top of the column with 1.533 in it, you get 0.20. So our p-value is greater than 0.20. In this problem, alpha is 0.05. So our p-value is definitely greater than alpha, which means we fail to reject the null hypothesis. And the null hypothesis was that the mean of the differences is 0. So we can say there is no difference in accuracy of forecasts 2 days or 4 days ahead. So the forecasted temperatures are not different from each other, given being 2 days away or 4 days away from the forecasted date. So our calculator will do this as well, and we'll see an example of that on the next page. Alright, so let's see how our calculator will do that same problem. Right, in your stat menu under tests, we're going to use a TTest. So it is a 2-sample test, but remember we've calculated the differences and we're just doing a test on the list of differences and comparing that to 0. So it's just a standard t-test. In this case, since I have data in list 3, I'm going to go ahead and show you how to do that one. So if we use data, the mean of the differences from the null hypothesis is 0, so we're going to keep that. The list of our differences is in L3, so we need to change this to list 3. Frequency, we're always going to leave at 1. That means we're just counting the list once. Our alternative hypothesis was looking for not equals, and we can calculate. So there's our value for t, 0.56, same as we got with the equation. Here's a more accurate p-value, an actual number. We were just kind of estimating what the p-value was from the table. And then it recaps the mean and standard deviation of your differences. So we get the same value for t. Our p-value is more accurate. We have an actual number. And it's definitely greater than alpha, which was 0.05. And we failed to reject the null hypothesis, which means there's no difference between the two predictions. Alright, critical value method. We have a value for t that we already calculated. And our critical value of t for alpha is 0.05, and it's two-tailed. And you'd get this from the table with degrees of freedom of 4. Our calculated t is less than or less extreme than the critical value of t, so you failed to reject the null hypothesis. And again, the critical value method is the least used method. The p-value is the more common. But let's look also at confidence intervals. So for a confidence interval, we need a critical value of t, which would be 2.776 from the table, where degrees of freedom equals 4, and alpha is 0.05. Standard deviation of the differences was 2.408. Sample size is 5. And you get 2.99 for your margin of error. Then the confidence interval, we're going to take the mean of the differences plus or minus the margin of error. So the mean of the differences was 0.6. The margin of error is 2.99. And 0.6 minus 2.99 gives you negative 2.39. 0.6 plus 2.99 gives you 3.59. Remember, we're looking for whether or not the mean of the differences is 0. 0 is in this confidence interval. Which means we have to fail to reject the null hypothesis, which stated that the mean of the differences is 0. So it's possible for the mean of differences to be 0, since 0 is in this confidence interval. All right, so let's see how the calculator can do a confidence interval. In your stat menu for tests, we're going to do a TInterval. And remember, we're using 2 samples, but we calculated the differences, so we would just have one list or one set of data. So we're using TInterval. We have the list of the differences stored in list 3. So let's use data. List 3, frequency is going to be 1. Confidence level that we're after, since alpha is 0.05, we want a 95% confidence interval, so we need to change that to 0.95. And we're going to calculate. And there it is. So exactly the same as what we got calculating by hand. And then again, it also recaps the mean and standard deviation for you if you needed to write that down. So all 3 of these methods reach the same conclusion. It's failed to reject the null hypothesis. And again, that just means that there is no difference in accuracy between forecasts 2 days ahead and 4 days ahead. So rewriting the conclusion in the context of the problem, there's no difference. The null hypothesis was that the mean of the differences equals 0, which means there's no difference.